Okay, this is more practice with logarithms from my quick review series. So what we're going to do is we're going to evaluate these four problems. We're going to write these in logarithmic form. We're going to expand all of these, and then we're going to write all of these as a single logarithm. So this video specifically continues extra practice exercises from my review video on the same topic. So if you want to see a review of how to do these problems, check the description for a link to the review video. And by the way, you can get a free PDF version of these problems with an answer key at divideandconquermath.com. Just go to the review section. Okay, so first things first, let's start with just evaluating these right here. So to evaluate, this is really in essence asking us to write in exponential form. So to evaluate something like this, one thing that I recommended in the review video is that you set up this dummy variable x so that you can rewrite this in exponential form. So this will be 2 to the x equals 1/4. And like I said, that comes directly from the definition. So I talked about this definition at length in the review video, but it comes from there. Okay, so now that I've set this up, 2 to the x equals 1/4. So now you just have to think about what exponent actually makes sense for that. And in this case, that would be the exponent that x equals -2. So if I were being asked to evaluate what is log base 2 of 1/4, that will equal -2. Okay, so for the next one, so we have the natural log of 1, and this is actually now using logarithm properties. So one of the properties of logarithms is that log of 1 just always equals 0. So we don't even have to do this whole setup up here. Since it's natural log of 1, this just equals 0. Boom, we're done. So C is also in the same vein of log properties. So we also have that we have log base A of A. So we have the same base and then number here. This is just always going to end up equaling 1. So this equals 1, and we don't have to think about it anymore. Now D, we are going to have to think about. And so you can set up that dummy variable there if that is helpful to you. And then you can rewrite this in its exponential form. So this will be 3 to the x equals 27. And that will only work if x equals 3. So log base 3 of 27 equals 3. So next, I just have a couple of problems here where we're going to write them in logarithmic form. So we just wrote everything in exponential form. So just to make sure we've got it down, let's write these in logarithmic form. So this is just straight up using the definition of a logarithm, which again is this part right here. And so you can pause if you want to read that over, of course. I am just going to use it. Oops, I'm in the wrong page. Okay, so this is going to be log base 5 of 1/25 equals -2. And I always say, so it's always the same base from the exponent, so base and base goes here. But logs are really, what power do you have to raise this to get this number? That is kind of the way that I think of logarithms. So if I want to do this again, so I have 3 to the 3rd equals 27. This will be log base 3 of 27 equals 3. So that would be in logarithmic form. Okay, so up next, we are going to expand all of this good stuff that you see here. So I am just going to review kind of 2 principles within these same 2 exercises before we move on to everything else. So in general, when you have a fraction like this, so general principle, and I talked about this in the review video and I showed why, so I'm just going to tell you it here. So anything that's on top can be broken up with addition. Anything that's in bottom can be broken up by subtraction. So I don't really have to think too much about how to break this up if I understand that rule. So this is going to be log base 3 of 7 plus log base 3 of x minus log base 3 of y. So again, anything that is in the top can be broken up by addition. Anything in the bottom is subtraction. So I totally honored that here. And so I can do that same thing here, even if I'm multiplying a bunch of stuff together. I can just break all of it up by addition. So this will be natural log of 4, natural log of x to the 6, and natural log of y. The only other thing with that, though, is when you have these exponents, you just want to remember to bring them out in front. And as you get used to that, you might not even feel like you have to write out these 2 separate steps. You might just be able to go straight to it, but I just want to do it in steps just in case people want to see that. Okay, So for this one, so I think this is a really great one to apply that principle of anything that's in the top, you will expand by addition. Anything in bottom, you'll expand by subtraction. I would try that here first, like what we did in the last problems, but I'm going to go ahead and just plow through this. So I'm going to have log base 5 of 5 plus log base 5 of x to the 5th minus log base 5 of y to the 6th minus log base 5 of z to the 7th. And so notice, right, so if it was in top, it got broken up by addition. If it was in bottom, I just jumped to the subtraction. So that is the rule that you want to rely on. And now from here, so remember, log base 5 of 5. So when it's the same number here and here, it automatically equals 1. So you just want to watch out for that. And then for the rest of these, I'm just going to take these exponents. I don't know where my exponent just went. I just lost it. I'm going to take these exponents and I'm just going to bring them out in front. So this is going to become 1 plus log base 5 of x, 1 plus 5 times log base 5 of x, minus 6 log base 5 of y, minus 7 log base 5 of z. Okay, so for this next one, so this is kind of interesting because we have this giant square root kind of ruling over everything. And so one thing that we just want to remember in the back of our minds is, so for this square root, I can rewrite this as an exponent to the 1/2. Now, by the order of operations, I cannot break this up quite yet. So the first thing I'm going to have to do if I want to break this up is I have to bring this exponent down in front. So I'm going to rewrite this as 1/2 natural log of 3x to the 5th times y to the 4th. And now that I've done that, now I can break the rest of this up. So I can rewrite this as 1/2, but I want to make sure I open parentheses so that that 1/2 applies to all of this. So this becomes 1/2 times natural log of 3 plus natural log of x to the 5th plus natural log of y to the 4th. And then these exponents here, I will bring them down. So this is 1/2 times the natural log of 3 plus 5 natural log of x plus 4 natural log of y. And, you know, it's a little bit of preference. If you want to distribute that 1/2 and keep going with it, that's fine. Do you have to? I think it just depends on the context of what you're using this for. I'll just leave it like that for now, though. Okay, and so for this next one, so now this is kind of the culmination of all the things that we've talked about. So for this next one, I've got stuff in the top, I've got stuff in the bottom. So what I'm going to do first is, I'm going to rewrite this top part as 6x to the 1/2, just so that we can visualize that. And then I've got y to the 7th, z to the 5th. Okay, so once again, I have to just be careful with how I break everything up. So I am actually going to be very slow with this one, just so we can kind of watch everything. So this becomes log 6x, all of that to the 1/2. So I'm going to leave that alone for right now, but I am going to write out the rest of these pieces. So these other pieces are not surrounded by an exponent, so I can just write them out like that. Okay, so the reason that I have to be careful with this is that this 1/2 has to apply to all of 6x. So this is going to be 1/2 log of 6x, and then I can break up that 6x. Now, for these other pieces, I will bring these exponents down. So this is 7 log y minus 5 log z. But now I can break up that 6x, and I just want to be careful, right? So I'm going to put a set of parentheses around this because this 1/2 has to apply to the whole thing. So this will be 1/2 times log 6 plus log x, and then minus all the other stuff. And then again, it's up to you if you want to finish this by distributing the 1/2, but this is good enough. Now, if you are finding this video helpful, I would love it if you hit that like button, leave me a comment to let me know how things are going, or consider subscribing. Okay, so now we're going to go the other way, so we're just going to write everything as a single logarithm. So just to kind of remind you guys of like how this works. So if it's positive, it goes in the numerator. If it's negative, it goes in the denominator. So in both cases here, we can just jump right to that. Now, what I do like to do first is I like to, the one step that I like to take is first I like to rewrite stuff with their proper exponents. So I'm going to rewrite this as the natural log of x to the 5th minus the natural log of y to the 3rd. But then I can see here, so x to the 5th is positive, so that goes in top, and y to the 3rd is negative, so it goes in bottom. So I can still apply that principle to this next part here. So again, first thing I'm going to do is just rewrite this so that the 4 goes up as an exponent. So this is log AB minus log C minus log of B to the 4th. But now I can rewrite all of this. So this is log, so AB was positive and what was negative? CB to the 4th. Now, the other thing that you'll notice with this, right, is that this B can actually be canceled out. So this will simplify to log of A over CB cubed. And so, yeah, that is totally fair game. You do have to watch out for simplifying things. It's all good. Just watch out for it. Okie dokie. So let's keep going with this now. So for this next one, so first things first, I just want to rewrite all of this so that the exponents are in their proper spot. And then I can rewrite this as the natural log of the square root of x over the square root of y. Now there is a little aesthetic thing that we could do here. So I could rewrite this as just 1 square root of x over y. So if you have a square root on top and on bottom, you can just compress it to 1 square root. All good. Okay, so for this next one, so we just got a lot going on here. So the first thing I'm going to do is just rewrite everything so that it has its proper exponent. So this is log x to the 5th plus log y to the 7th minus log x squared minus log z to the 9th. And then I'll just write this. So the things that are positive, x to the 5th and y to the 7th. The things that are negative are x squared and z to the 9th. Now, you may have noticed that you can do 5 log x minus 2 log x. If you notice that, that's all good. I'm about to simplify to that same answer. But if you just plowed ahead, now you're going to have to simplify things. And so in simplifying things, this x squared is going to cancel out, so I can subtract it from here. So my final answer will be log x to the 3rd, y to the 7th over z to the 9th. Okay, and we have one more here. So let's see. I notice in this case, so I've actually kind of written this to throw you off. So you'll notice that I have AB is positive, but also, dun dun dun, log of CD, that's also positive, right? So I'm actually just going to write all of these together, AB, CD. And then what's negative is this BC. And now you'll notice, okay, the B and the C can cancel out on top. And so this whole thing is just going to equal log of AD. Sorry if you can hear my dog barking in the background. You know, the mailman showed up, and let me tell you, the mailman is not getting in here. There she goes again. Okay, so that is it for this video. So I will talk to you guys in another video. Bye!